GCSE Physics, Developing the Model of the Atom, SMARTPATHTUTORING. Rutherford replaced the plum pudding model with the nuclear model. In 1804, John Dalton agreed with Democritus that matter was made up of tiny spheres, atoms that couldn't be broken up, but he thought that each element was made up of a different type of atom. Nearly 100 years later, J.J. Thomson discovered particles called electrons that could be removed from atoms, so Dalton's theory wasn't quite right. Thomson suggested atoms were spheres of positive charge with tiny negative electrons stuck in them, like fruit in a plum pudding, the plum pudding model. However, in 1909, scientists in Rutherford's lab tried firing a beam of alpha particles at thin gold foil. This was the alpha scattering experiment. From the plum pudding model, they expected the particles to pass straight through the gold sheet, or only be slightly deflected, but although most of the particles did go straight through the sheet, some were deflected more than expected, and a few were deflected back the way they had come, something the plum pudding couldn't explain. Because a few alpha particles were deflected back, the scientists realized that most of the mass of the atom must be concentrated at the center in a tiny nucleus. This nucleus must also have a positive charge, since it repelled the positive alpha particles. They also realized that because nearly all the alpha particles pass straight through, most of an atom is just empty space. This was the first nuclear model of the atom. This then developed into the current model of the atom, the nuclear model that resulted from the alpha particle scattering experiment was a positively charged nucleus, surrounded by a cloud of negative electrons. Niels Bohr said that electrons orbiting the nucleus do so at certain distances, called energy levels. His theoretical calculations agreed with experimental data. Evidence from further experiments changed the model to have a nucleus made up of a group of particles, protons, which all had the same positive charge that added up to the overall charge of the nucleus. About 20 years after the idea of a nucleus was accepted, in 1932, James Chadwick proved the existence of the neutron, which explained the imbalance between the atomic and mass numbers. The nucleus is tiny, but it makes up most of the mass of the atom. It contains protons, which are positively charged. They have a +1 relative charge, and neutrons, which are neutral with a relative charge of 0, which gives it an overall positive charge. Its radius is about 10,000 times smaller than the radius of the atom. The rest of the atom is mostly empty space. Negative electrons, relative charge -1, whiz round the outside of the nucleus really fast. They give the atom its overall size. The number of protons equals the number of electrons, as protons and electrons have an equal but opposite charge and atoms have no overall charge. Electrons and energy levels can move within or sometimes leave the atom. If they gain energy by absorbing EM radiation, they move to a higher energy level, further from the nucleus. If they release EM radiation, they move to a lower energy level that is closer to the nucleus. We are currently happy with this model, but there's no saying it won't change, just like for the plum pudding. New experiments sometimes mean we have to change or completely get rid of current models. Thank you for watching. Please don't forget to subscribe and like the video.